Hello, today we're going to discuss how to manage projects under uncertainty. Consider the house building example depicted in this slide that involves 7 activities. For each activity we have its description, its immediate predecessor, and duration in days. We wish to figure out how long would it take to complete this project. To do this, we draw a project network and find the critical path. In this case, the critical path is activities A, B, E, F, and G, and its duration is 29 days. Also note that the other paths in the network are significantly shorter. Now let us consider the more realistic scenario in which we don't know the exact activity duration, but we have an estimate of the most likely duration as well as the minimum and maximum durations, like we see in this table. We would like to find the expected project duration as well as the probability that the project will be done within a certain amount of time. To do this, we first calculate the expected duration for each activity using a weighted average according to the weights given in the 5th column of the table. Once we calculate the weights, or the expected durations, we replace the previous activity duration with these expected values. The expected project duration is given by the sum of the expected durations along the critical path, which again happens to be 29 days, even though the sum of the activities' expected durations are different from before. Again, notice that the durations of the other paths are much shorter, so that we can ignore these paths and just focus on the critical path for the purpose of our current calculations. Next, we would like to find out the probability that the project will last more than 30 days. To do this, we will use a normal approximation of the project duration, which is justified due to the central limit theorem. So we're going to compute the z-score using d as 30 days minus te as the expected duration of the project, which is 29 days, and divide by the standard deviation of the project duration. To find the standard deviation of the project duration, we need to find the standard deviation or the variance of each one of the activities, and then the standard deviation of the project duration will be equal to the square root of the sum of the variances of the activities along the critical path. So the first step is to compute the variance of the duration of each activity according to the formula that appears above the table. So once we do that, we're going to look at the critical paths, again A, B, E, F, G, and we're going to sum up the variances along this critical path to get the variance of the entire critical path, which is 0.83, and then the standard deviation is equal to 0.91. Therefore, the z-score is equal to 30 minus 29 divided by 0.91, which is equal to 1.10. Now we look at the standard normal distribution, and we look at the z-score of 1.10 to see that the probability that a normal random number, the probability that it's less than or equal to 1.1 from the table is 0.8643. So once we find this, we can then say that there is an 86.43% chance that this project will be completed within 30 days. And this answer can be used for us to design a contract that will allow us to think about what's a reasonable penalty to pay if the project is not done on time. A second method that we have for calculating the probability of finishing the project within 30 days is using simulation, which is a tool that we covered a while ago. The idea would be to look at the distribution of the duration of each of the activities, collect data on those, simulate their durations, find the critical path, repeat this a number of times until you feel confident that you have a good estimate of this probability, and you would use that. The advantage of using simulation versus the normal approximation is that simulation requires very little in terms of assumptions. You can have correlations between the activities. You don't need to assume anything about normal distribution. So that's a very useful method. So to summarize, we have covered the entire topic of project management, and what we did today is focusing on the method of looking at project management under uncertainty, specifically focusing on normal distribution and simulation.